Hey everybody and welcome back to the shop. Today we have a new design for the chamber heater shroud thingy right over here. So this is the stock design. I made a scan out of it. These are the design iterations and the final piece is in there doing all the work. But first of all, I want to thank you, the community, for including me in everything by sending me emails, by sending me links to the Reddits and to Discords, or just talking to me about your experiences. Thank you so much. If you are done watching the video, you will find the links down below. These will be free for you to download, so grab the files, print it in any glass-filled material that is going to be better than ABS. So in my case, it's going to be a nylon. And if you found this video helpful, please give me a thumbs up. So consider subscribing to the channel. We have more content coming up. And if you have a bit of spare change lying around, there's also a link down below to buy me a beer. So first of all, I'm going to give you a big warning. If you are going to try and attempt this fix, then please know what the hell you are doing. You don't want to work on this printer when this thing is powered on. So you want to start with turning this thing off, removing the cord, and then you can start removing the parts that need to be replaced. Replacing this part is going to be very easy. There's just a bolt right here on top, and right here in the bottom there are two holes. You have to turn around the printer. There are two bolts you have to remove, and the whole thing just pulls out. Right here on the back there are two strips with double-sided adhesive, and you can just yank it off the foam and you have it in your hand and you are ready to replace these parts. Also make sure that if you are going to choose a filament, that you are not going to use any filament that has a carbon filled anything. A lot of people don't know that carbon fiber is conductive, so if you are going to replace it with anything that is going to be filled, please use a glass filled fiber. Glass is going to be a great insulator against heat, but it is also going to be a great insulator against electricity. So the filament that I use today is going to be the Polymaker Polymite PA6 glass fiber. This is not sponsored by Polymaker. I have purchased this for myself, but all the rest of the filament that we have used and this box right over here has been sponsored by Polymaker in order for me to do all the work I do today and all the work we are going to do in the future. We are also going to talk about the SSR issue on this machine. Also the very frustrating process I have been going through the last 2 or 3 weeks, because a lot of the information I was receiving was contradicting everything I was experiencing with my printer. This is how the stock chamber heater works. We have a massive blower fan. We have an AC element right over here. Don't touch this. This is super dangerous. Right over here where we live is 220 volts. If you're going to touch it, you're going to get zapped. So this is what it should look like. We have our probe right over there. We have our heater sitting right up there. Then we have our fan housing. This is going to get clamped down using this shell right over here, and we can also see that the plastic print actually started tearing. So in the next design, the design that I'm going to share with you, I'm going to expand the wall thickness so the tearing of this wall is not going to happen. So consider it fixed up front. But right now the only thing I have to do is just bolt this thing on there. And with that we are going to use some self-tapping screws. These are just your normal wood screws, and these should do a perfect job of containing the clamshell together. So if you don't have the correct size, you can just snip them off. I have done it also. Look, like you can see, I have just snipped them off. And there we have it. Everything is nicely packed together. We have the fan in there, we have the probe in there, the heater is in there. The only thing that I have to do is just mount it to the side and do a little test run. As you can see, the replacement heater is in, and now it's time to fire it up for the first time. Now I can feel that the fan is running great. So right now I'm really happy with the design. It seems that all the air is pushing between the rods and not on the rods. But most importantly, there is a nice amount of airflow going that way instead of going all the way to the heated bed. We have disassembled the heater, and we can see that these tabs right over here, that these are starting to melt a little bit. We can see that they are nice and shiny and these don't. So this means that the ABS print definitely got too hot. We are starting to see the melting points right over here. Polymite 6GF, I think it is. This is a glass-filled nylon, and this should resist the heat that is going to be inside of the heater, but it was not without the faint of heart, because you can see right over here there is a big line here in the middle. This is not because I did something stupid or special, but do you guys remember that this printer was plugged into something smart? Now this fucker right over here almost screwed me over, and this is part of my home automation. This means that after a certain time period in my day, this will turn off, and because most of the time if I'm going to do some kind of a long printing, it's going to be just before I go to bed. I woke up in the middle of the night thinking, fuck! This thing is turning off, so I rushed down butt naked to the shop in order to see that this eagle was down. So it was already cooled for about, I think it's going to be 5 degrees, so we were still having bad adhesion. Luckily, there is also some hairspray on the flex plate, and the line right over here, we were able to continue the print, so I just plugged it into a normal socket. We continue the print. The only thing we can see is that the Z offset after resuming the print seems to be not that optimal, but I am just lucky I didn't waste a 20 euro print, because the spool, the Polyamide 6GF, is freaking expensive. It's about 50 bucks for half a kilo. So I would cry my ass out, or at least I would feel very bad because you guys paid for this. Alright, so all the bad news is done. Right now we are going to remove the ABS part. Believe it or not, the ABS part has been sitting in there for 24 hours to do all the printing, so for the back and for the front. So a few things have changed. We can see we have increased the wall thickness. So this is to compensate for the shearing of this little piece when we are trying to jam in this little block right over here. This little block is to facilitate the wiring so it doesn't pop up when you try to screw it down. So you can see this is just a press fit. Now the cables will run under there, so it's going to be more easier to handle. One last admiring of how this thing looks. The glass fiber looks really nice. I'm also very happy with the design. I think I did the best job ever in designing anything. The testing already seems that this design is sufficient enough to heat up the chamber, and this part is even more crazier. We could see we are having some indents, we have some airflow considerations, we have some gaps right over here for the silicone sock of the heater and all. And then we have these features right over here. This is going to encapsulate this part right over here, so this doesn't move a lot. So once this is sandwiched, everything is going to be nice and tight. We are back. We have tested the heater at the full capacity of over 400 watts for about, I think it's going to be 6 or 7 hours, with a few heat cycles going from almost close to ambient temperature, heating it all the way up and back and forward, back and forward. We also updated to the latest firmware. I discovered a few things. I have to scrap almost everything I said because, yeah, it's just not making sense with everything I'm reading, and I'm going to tell you what I mean about it. But first, I'm going to take a look at my clamshell design to see if we can see any melty stuff going on. I have noticed clamping the shell that there was a little bit, not enough of clearance with the heater, so it's clamping on the heater, which is not a bad thing in my opinion, because the heater can slide out, making it go crooked and all of that. So a little bit of a clamping force on the heater is not going to be a problem. What is going to be happening, I think, is we are going to get some spots where we are going to see some glossiness going on, like we could see with the ABS part, but we rammed more than 450 watts through that heater and through that nylon part. So yeah, really interested to see what is going to happen. So right now I'm going to remove it to show you how it looks inside. Then I'm going to put it back in there, and we are going to do some comparisons with the PWM signal. Because of the reasons I discovered, my sample is actually a completely different heater with a completely different power output, and basically with the new update with the 0.4 PWM setting, this heater right now is not even close to putting out 100 watts. So basically it's now just an expensive paperweight heater. So yeah, here we have it, the last test, and I think you can see it on my face. It just absolutely worked. It just ate the 400 watts. I'm so freaking happy that we found a filament that is actually able to resist the absolute madness of heat we have put in there. We have reached more than 400 watts of heating capacity through this part. This is just a 3D printed part. I could not be more happy. So like you can see, the stuff you can see right over here is just from the lead screws, the grease, but normally there would be a hot spot right over here. This is just looking absolutely perfect, like $1,000,000. So this is the part where the heater is touching, and we can see the smallest shiny part right up here. So yeah, this is absolutely perfectly fine. This has tolerated the heat just like a champ. And then we have the problem part, and this is going to be the same story. We can see that all the teeth, they are not even shining, so these didn't get all too hot. And if we look at this part, we can see the faintest little bit of shiny spot on that teeth right over here. So yeah, it looks like the print is actually just fine. I'm super happy, so this means that I am finally done with designing this stuff. We have reached the stage that I can full-heartedly say, yes, this is going to be the part you want to replace it with. And every glass-filled nylon, you will have to look at the TDS, look at what the melting temperatures are going to be. But I can already say that the polyamide PA6 glass fiber reinforced one is going to be fine, even at 0.7, which is way over 400 watts. But I'm going to show you how we can compensate for that. I do agree that putting more than 400 watts into the system isn't necessary in the first place, and it is probably also going to degrade your heater faster. So now I'm going to show you on the laptop how we are going to change some code lines, and we are going to do some A/B comparisons on what the PWM is going to do on my heater. All right, we are back, and like you can see right in front of me, here are all the design parts. Going from your left is going to be the original part, going in with some PLA, and the last one right up there, the black one, is going to be the ABS one that has seen some heat at 0.5 PWM. So right now you have a view of the fluid interface and my phone, which is going to show you the idle power, which is now 35 watts. Watch what happens when I turn the chamber heater to 1 degree. It is going to spin up only the fan. The heater is not going to do anything, but this is going to give us a nice baseline of what it is going to be without the heater. This is cave style type of investigation. I don't have the fancy material to do some clamping and just measure the amperage that is going through the system. So right now we can see we are pulling around 50 watts through the system without heating. So this is going to be idle consumption and the blower fan that is in the chamber heater. So we can now deduct around 50 watts of the total temperatures that we are going to see. Right now at 230 volts, we have 0.3 of an amp, so we are basically using almost nothing. Now, the people in the US will see almost double, and they will be way closer to 0.8 of an amp on total power consumption. Now we are on the new firmware, which means that this printer got nerfed to 0.4 PWM signal, which is going to mean that this printer in theory should be a little bit under 400 watts from the reports that I could see, but on this machine we are going to start the test right now. We can see that the power will steadily increase. I'm going to let it sit a little bit, and then we are going to come back and see what the actual power consumption is. But spoiler alert, if we are going to watch now at the power figure, we can already see we are below 200 watts. You have to deduct 50 from it, so we are under 150 watts of total power consumption. It has been a few minutes. The system had some time to heat soak, and we can see that the total power consumption right now is going to be 200 watts, deducting 15 from it. So this is now a 150 watt heater. And now I'm going to show you what you have to do to try and get more in the neighborhood of that 400 watt mark. Then we are going to the configuration button. We are going to press it. Then we have printer.cfg, you're going to press it, and then right around line 267 right here on the left side, you will see heater generic chamber. And right there you have the max power figure of 0.4, which is what they changed in the last update, and we are going to change it back to 0.6. We are not going to do 0.7. I will do it for demonstration purposes, but in order to match what we could see of our American friends and our European colleagues, I'm going to do a save and restart, and we are going to look what is going to change this time. So the printer rebooted. We are going to put in the 65C. We can see right here at power, we are at 60%, so we raised the power output by 20%, which means that for our actual power consumption, we are right now seeing 288. This is going to go over 300 watts. So like previously, I'm going to give it a few minutes, let it heat soak, and I will circle back. it has been a hot minute. We are at 440 and a bit watts, which is going to be a little bit shy of the 400 watts that this system is rated for. So the 0.6 PWM setting is more in line with the spec. So I'm going to leave it at the 0.6, but for shit and giggles, I'm going to put it to the 0.7 to see what this printer came stock at and what the heat capacity is going to be at 0.7. Spoiler alert, it's going to be a lot. We are back. The PWM setting of 0.7 is netting us a total power of 521 watts, which is going to be more in line with 470 watt of total heating capacity, bumping this system up with about a good 80 extra more watts, which is actually out of spec. And this is where we are going to get into the topic of the SSR, the issues around the SSR, and the answers that Qidi gave us in correlation with everything we are going to talk about. So to close this off, I think it would be very interesting that you put this printer on some kind of a smart plug where you can do the same thing as me and do a little power inspection to see what kind of heated element is in there. With the stock PWM setting of 0.7, you should get a total power output. Just the chamber heater with the fan alone is going to be right around 520 watts. So I would say somewhere between 500 and 550 watts because no heater is created equally. With the 0.4, you will see that the heater just became a total paperweight. It is actually barely usable. So I would recommend to set your setting back to the 0.6 manually. I'm going to show you one more time how to do it. We're going to press configuration, printer.cfg, then at line 267, you want to change it from 0.7 to 0.6, or if you have updated to the latest firmware from 0.4 to 0.6. Save and restart. The system is going to reboot. This is going to take a second or 10, and then you will see when we are back at the main screen and we type in we want 65 degrees, then the power output is at 60%, and we can see right here on the meter that we are going to start seeing we are back to 440 watts. We are actually getting close to the 550 watts. Like I mentioned, the hotter this thing gets, the bigger the power consumption is going to be. So we are now very close to 61 degrees Celsius. So this is the 0.6 is going to be in line with the spec of the 400 watts. And you can play around, you can fine tune it, you can put it at 58, 59, you can put it at 7 if you want. It is all up to you. If you are having 220 volts right now, it seems that it's going to be perfectly safe to play around with these numbers on the SSR that is in there. We are going to do a final inspection on the video from my after 1 month review. We are going to remove the back panel and do some investigation of our own to see if it's actually fine. But spoiler alert, somebody else checked it for me and it is actually fine. The SSRs are only getting around, I think it was between the 60 and 70 degrees mark, which is well in line with the call specifications. All right, enough rambling about the heater. Now let's talk about the SSR issues. Oh, and one more thing I want to add, I forgot it almost. We have the chamber thermal protection sensor. This is also a type of sensor that I would change in config because right now it is set to 130 degrees. And we are going to change that out because from my testing at 0.7, we are not going above 80 degrees. So to reiterate, we have to go to the printer.cfg. At line 290 is going to be the temperature sensor, chamber thermal protection sensor. And we are going to drop the max temperature from 140 to 90. Then we are going to do save and restart. And now we have set a new value for the chamber thermal sensor. And right now let's talk a bit about the SSR in this system. So it seems right now that the SSR is perfectly fine when we are using it in a 220 volt system. So right here in Europe, almost every place is at 220 volts. And it looks like the SSR is designed for a system capability of 220 volts. Now, our American friends also received this system with the same SSR, and it is there that the problem lies. The The SSR at 220 volts is perfectly fine with the amperage, but when we drop it to 110, then the amperage will double because you have lower voltage. This is just the basic law of Ohm or power or whatever it is called. So to answer some of the questions, is it safe at 220 volts? Well, the testing seems to be that it is perfectly fine. Even at 0.7, it is perfectly safe to use this SSR. The coils are not going past the 7 degrees. Now, a lot of people on the Reddits and on the Discord channels right over there, people with a lot more knowledge did a good inspection of the board, and they could see that it's actually not the SSR that is burning up, so the solid state relay, but it is the coil. It is an induction coil, or I don't know what the coil in the middle is, but the coil that is doing something is getting way too hot and it is burning up. And we could see that it's actually the radius in the middle and everything around started melting. We could see some videos from people having smoking SSRs. They have replaced it with the new SSR from Qidi, and even on the same day it started smoking again. So it is definitely an issue. Some new information grabbed my attention. 3D Musketeer opened the back of the printer and he did some actual video study on it, and he could see that the coil on his system was reaching over 170 degrees on the 0.4 PWM.
Someone on Discord pulled the plug at 180, it'll keep going. Yeah, I'm gonna go ahead and stop the test here. I'm not going to let it go any further. It is getting into the realm of incredibly unsafe.
So lowering the PWM is definitely not going to be the fix. So right now, everybody that has 110 volts, even with the 0.4 PWM, has an unsafe system and a potential fire hazard. The SSR is encapsulated with a plastic cover that they claim is fire retardant. I have seen proof from Boyd on the Facebook Qidi groups that it's actually not that true. It's just happy to catch on fire. So right now I would not advise you to buy the Qidi Plus 4 if you are in a 110 volt region. This has been proven that it is a fire hazard and that they are not doing enough to fix the issue. The SSR needs to be replaced, and it needs to be replaced in a way that this is not going to happen in the future. Now there are pictures arising, I think it was from yesterday, that they are working on a new coil with a thicker wire gauge. I'm going to show you a picture. This has been untested, so I cannot say if that SSR is going to be the fix for that problem. Also, Qidi is doubling down on it. They are giving you an extra 1-year warranty on the SSR, and they are only going to send you an SSR if you are going to experience problems. Now, the people on the Discords and on the Reddits and even 3D Musketeer has shown that the SSR is unsafe. So waiting for this to smoke up and then having to ask a new SSR is not what I want to see. I want to see a recall on the product. The recall can come in many ways. It can be by sending over new parts, but you have to say to the people officially and out loud that 110 volt products are an issue right now, and that the PWM changes that you have done in the last firmware are not enough to fix the issue. So everybody that now has the 110 volt, I would highly recommend to not use the chamber heater right now until you have proven SSR replacement parts. So thank you 3D Musketeer for doing your research. Thank you for, I think it was 802 Garage, for sending me the new pictures of the new SSR they are trying to implement. But like I said, right now it's unclaimed. We will see what's going to happen with that. Now the problem, as we established, is that they are iterating very fast. I already have another chamber heater that the people are receiving right now. So this is the old style. We have a very big hole in there. So this is probably Gen 1. There is already a Gen 2, which the hole right over here is going to be a lot smaller, and this is to compensate on the audio signal. They want it to be quieter, and instead of changing the fans, they are choking off the fan, making it more silent. So we are seeing people that are having chamber heater issues, that they are going over those 130 degrees mark or the 140 like they said now. So now they are choking off the fan, so they are making it even worse and worse, the chamber fan. So if you are experiencing issues, I would definitely give it a try, pick one of my designs and try to print it. Because like I said, they are doing a lot of design iterations. I can only guarantee that if you have this type of heater, that it will work, it will be a drop in replacement. And I hope they only changed out the design of the shrouds and everything on the inside is stayed the same. And if they are using a different heater, it's just the power output and not the overall dimensions. If that's the case, let me know down below. It is going to be very hard to redesign it if I don't have the new heater with the lower or higher heat capacity. So yeah, if it doesn't work, let me know. It is so important to let your customers know what the hell is going on, what you did wrong, and what you are doing to fix it. Now, I am not mad, this is free content for me, but it is frustrating getting 10 mails a day from concerned people to having to say the same thing over and over again. Just one simple official statement would fix all of that, and it will show the people that you actually care what they are talking about. Now, I am very convinced that they at some point will get it, that the SSR is not what it should be, and they will change it out, like some other things that are going on in the printer. So I think everything with time is going to be fixed. And like they said, you get an extra 1-year warranty on the SSR. So they are trying to do the good thing. The only problem that is so frustrating is that they always try to do the right thing behind your back without talking about it. They are not owning their problems and they try to wipe everything under the rug so they don't have to talk about it, and I would like to see a little mentality change in that. We can conclude by just changing the design, we have effectively fixed every issue with this printer, and all the firmware hacks that Qidi was implementing can now be removed. Now, the chamber turning off at 270 millimeters, I have no clue how to turn it off. If you know, put it down below in the comment section. I would be very interested to be able to turn that freaking feature off, because we can see it is actually not necessary anymore. So Qidi, if you're looking at this and you think that's a great design, just go download it, make an injection mold of it. I don't care, maybe leave my name on it because free advertising, and maybe send me some of your finest PPS spools just for me to compensate me for my time. Alright, so guys, that's going to be it. Thank you so much for incorporating me in all the discussions and sending me all the stuff, just also supporting me directly, the people that became a member just to help me out, and even these members right over here, thank you so much. You are the bread and butter of the channel. And guys, if you're still watching, thank you very much. Maybe consider subscribing, and otherwise I see you in the next one.